Welcome friends. So we have previously discussed the three fundamental components of electrical engineering that is used in case of any network: resistance, inductance, capacitance. Now in this part of this lecture we shall discuss some commonly used components in circuit analysis or network analysis. So we shall discuss in this part some commonly used terms or components. Now the first one is independent and dependent source. Now what is an independent and what is a dependent source? Now the independent source is one that is the strength of an energy source does not depend on the other network parameters. Suppose you have a network. You have connected a battery across that network, any network, okay. Now this battery, let us say you have connected a 12-volt battery. Now this 12-volt will not change. 12-volt will not change under any condition of this network, okay. So irrespective of any condition of this network, this voltage remains as it is. So it is called independent source. However, in case of a source, if it is dependent on some other parameters, it is called dependent source. So it is of two types, it is of four types. First one is VCVS, voltage control voltage source. So it is a voltage source dependent on some voltage. Second one is voltage control current source. So it is a current source. Its magnitude is dependent on some voltage. Third one, CCVS, that means it is a voltage source. Its magnitude is dependent on some current. And fourth one is CCCS, that means it is a current source. Its magnitude is dependent on some other currents. So we have four dependent sources: VCVS, VCCS, CCVS and CCCS. Now if you consider figure 9, let us quickly review some well-known symbols. Now for independent source, it is always given by this symbol, that means a circle. It is a AC source, it is a DC source. Now this is a battery. This is a battery. So these first three are all independent source. Now the later four one, it is given they are all dependent source. They are all given by this rhombus like structure, right? So you see this arrow means it is denoting some value of current. So it is actually a current source, but it is written alpha into V. What is the meaning of alpha V? That means the magnitude of this current source is dependent on voltage, and alpha is some scaling parameter. So depending on this value V is the voltage of any network under across any component. So this current magnitude is dependent on this alpha V. So let us consider if alpha is 2 and if V is 5 volt, then this current magnitude will be 10 ampere. On the other hand, is alpha is 2 and now if V is 2.5 volt, then the current magnitude becomes 5 ampere. In this way, it is dependent. Now similarly, it is alpha I. So this is current source, the second one. This is the current source. Now it's depending on some other parameter I. So it is the current control current source. Now this one is the voltage control voltage source. It is plus minus, that means it is a voltage source. all represented by a rhombus like structure like this. So plus minus means it is the polarity of the voltage, so it is a voltage source. Now its magnitude is dependent on alpha V. That means magnitude of voltage dependent on some other value of voltage. So it is a voltage control voltage source. And the last one is the current control voltage source, alpha I. Okay. So the next item is, or next term is, linear and non-linear network. What is their definition? Now a linear network is one. Suppose you have a network. Suppose you have a network like this. It could be a linear network, it could be a non-linear network. Now under which condition you say a network is a linear and a network is a non-linear? The reason, the answer is, suppose if I vary my input by 2 units, that means let us say I am doubling my input. If I doubling my input, then my output will be also doubled. Output will be also doubled. So it will follow a linear characteristics like this. So it is a linear network is one when output varies linearly with input. If output is multiplied 2 times, input is multiplied by 2 times, output will be double. If input I am making 5 times, then output will be 5 times, something like that. So it is found typically in case of a resistance. If the output does not follow this nature, so if I make, or if I double my input, output will not be double but something other than double, then it will not follow the linear characteristic. That is why for those cases it is called non-linear network, which we can see this type of network in case of a diode network. Okay. So diode is a non-linear network, or non-linear element rather, and resistance is a linear element. Now third term is called active and passive network. What is active network? A network that capable of changing its energy level is called an active network. Now if you have a battery, if you have a semiconductor devices in your network, it is called an active network because it can change its energy level. However, if a network only allows the passage of the signal to flow, it's called passive network. Now it has nothing to do with the energy changing capability. It is only just there to provide a path to energy or to signal to flow, whether it is a voltage or current. It is there to flow. It is provide a path. It will provide a path to flow. That is why it is called a passive network, having example resistance, inductance, capacitance. Now next item, it's called unilateral and bilateral network. Very important. Let us consider this diagram, figure 11. Let us say this resistance. Now if you connect a battery in this fashion, and if you connect the battery in this fashion, just reverse polarity, for both of the cases a current will be flowing through that resistance. That means the current is independent of the potential of the polarity. Current I is independent of polarity of the potential. Polarity of the potential. So it is called bilateral network. On the other hand, if you consider a diode, now if a voltage or source is connected in this fashion, a current will definitely flow. However, if you connect the voltage source in the reverse manner, then no current should not be flowing. No current should be flowing through the diode, because the diode only allows the current flow in the only one direction. So the direction of the current flow matters. Direction of the current flow matters as a function of the polarity of the potential. So this is called forward biased. This is called forward biased, and this is called reverse biased. So a diode conducts in case of a forward bias, it blocks in case of a reverse bias. So it is an example of unilateral network. Now next item or next term is called node mesh loop. Now if you consider this network, what is node? Node actually it's a point where several elements meets. Let us say A is a node, B is a node, C is a node. In this way, all these are nodes. What is a mesh? Mesh is, this is a mesh actually. Mesh is a closed path containing no other path in it. Mesh is a closed path containing several network elements with no other loops in it. That means mesh is only, it is the symbol of closed path, elementary closed path. Okay. Now what is loop? Loop is, this one is a loop. It can contain more than one mesh. Okay. So the definition of node is a junction point where all the several points or several elements can meet. Mesh is a closed path. Mesh is a closed path with no other loop in it, and loop is also a closed path. However, difference of loop and mesh is that a loop can contain several network elements with one and more loops. So a mesh does not contain any loop. It is an elementary closed path. However, loop can contain several mesh or several loop inside of that. So if you consider now for this example, figure 12, A, B, C, D all are nodes. However, if you come H, G, F, E, they are all same nodes. They are not a separated node. They are all same node. That is why I have mentioned in this way. E oblique F oblique G oblique H. Why? Because you see all these nodes, their potential is 0. Their potential is 0, so they are all considered to be the same node. So the node is characterized by its potential. If the potential of any node or two nodes are same, then those two nodes are considered to be the same node. Now coming to the mesh, you can see ABGH, this is a mesh. ABGH, this is a mesh. Again BCFG, this is a mesh. Again CDEF, this is a mesh. CDEF, this is a mesh. Now coming to the loop. Now the first loop could be ABCFGH. ABCFGH. The second one could be BCDEFG. BCDEFG. And third one could be the entire thing. ABCDEFGH. ABCDEFGH. So mesh is the elementary or the smallest closed path which contains no other closed path inside, and loop is the Not it is also a closed path, but it can contain more than one mesh or loop in it. Now next term, it's called supernode and supermesh. What is that? Now consider figure 13. If you say, if you consider node B and node C, if you consider node B and node C, you do not know what is the resistance value of this branch B and C. So due to this fact, you cannot apply any KCL equation. I'll tell you what is KCL later on, or current equation. You cannot, or in simple term, you cannot evaluate what is the current flowing through this voltage source. So that is why what is the idea is that B and C, these two nodes are considered to be a single node, and it is called a supernode. So when a voltage source is there present, when voltage source is present or connected between two nodes, then these two nodes are considered to be a supernode. Now similarly, in case of two mesh, in between we have a current source only, then I do not know what is the voltage drop across BG. What is the voltage drop across BG? We do not know what is the voltage drop across BG. So for this purpose, we consider this mesh number 1 and mesh number 2 are super mesh. They are same mesh. If you club them, it will form a super mesh. So two different meshes are considered to be the super mesh if the current source is common to both of them. So node B and C are called supernode, and mesh ABGH and BCFG are called super mesh. So this is the idea of supernode and super mesh. We shall use these terms in later part of this course. So we are stopping here. Now in the next part, we shall discuss some numerical problems on resistance, inductance, capacitance. Thank you.